Hello students, hope you are doing well for the competitive examinations. Now the main purpose of this video is we are going to see the complete overview of the subject, the digital logic, not only overview, okay, a little of in-depth of certain concepts, and also we will see some tips and tricks, and let's see some different types of questions in the subject, and also some shortcuts related to the subject. Now, our main focus will be on GATE syllabus, but however, what you're seeing on the slide is these are general syllabus or the common syllabus for most of the competitive examinations like GATE, ESC and some of the PSU competitive examinations. But in particular, I'll be dealing with the GATE and in general about the other competitive examinations. Now you can just see the complete GATE syllabus for digital logic design you can categorize into 5 topics. The first topic, the basics. The second topic is the combinational logic. The third topic is sequential logic, and the fourth is semiconductor memories. And if you just see in the semiconductor memories, the PLAs actually is not a memory. Okay, it is actually a programmable logic device where you can implement combinational logic circuits. We'll come into that part afterwards. And the fifth one is data converters, and the sixth part is the microprocessor 8085. So these the syllabus of GATE digital logic design, or simply you can call digital electronics, okay, or you can call digital systems. And these are the common syllabus both for the EC as well as triple E. Now the first part, you can just see the basics of digital. First of all, why there is a lot of importance to the digital? Now nowadays if you just see the past papers of GATE, in the past papers the weightage for digital subject was less, but if you just see the recent years, for the past 5 years, if you just see, the weightage for this subject has been increased. Previously it was 5 marks, the average marks I am telling you about, 5 marks, afterwards it was 6 marks. Okay, you can consider 1 mark as 1%, previously it was 5%, 6%, 7%, and recently in GATE 2019, around 11 marks came from this subject in an ECE subject, in the ECE. So why this much importance? You know, everything is nowadays becoming digital. So without digital, it is impossible to imagine the life. Everything is being digitalized. So maybe that is one of the factors which is influencing the subject. Now let us move into the subject. The first topic, basics. The basics of digital. The basics of digital is, first you can just see the number systems. Without numbers, it is difficult to imagine anything. If you want to calculate anything, if you want to do anything in mathematics or in the electronics field or in the engineering field, without numbers it is difficult. In particular, in this subject, the number systems play a vital role. If you want to store anything, numbers are very, very important. In the electronic domain, especially in the digital domain, the numbers are stored in a form of bits. Wherever there is a voltage, it is considered as bit 1. Wherever there is no voltage, it is considered as bit 0. However, not a particular voltage, but a range of voltage is considered as logic 1 and a range of voltage is considered as logic 0. And based on this, there are 2 different types of systems in the digital. There is a positive level logic system and the negative level logic system. And there is of course one more system called as a mixed level logic system, which will include both the positive level logic system and negative level logic system. What are these systems means? Basically, if you want to store some numbers or some data or some information in a digital format, you should have a system. Without having a proper system, it is not possible to store some information. So working with number systems in digital is very important. Why? Because if there are no numbers, you cannot have any information. So whatever the information you store in the digital, they are in a form of numbers. For example, you want to store a movie, they will be in a form of numbers. okay, bits, zeros and ones. If you want to store, okay, some facial recognition data, that will be in form of numbers. Now, what numbers? Now, in the real world, the numbers what we see is the decimal numbers, okay, and these decimal numbers, deci means 10, there will be 10 symbols, whatever the number you write, you will be using only these 10 numbers, okay, 10 symbols, that is 0, 1, 2, 3, so on till 9, hope you know this. But this is the common system, this is a common number system what we call, and since there are 10 symbols, the radix we call 10, but if we are coming to the digital part, you cannot store directly 9, you cannot store directly 8. So, the system only recognizes zeros and ones. So, a separate binary language is given to it, that is, okay, binary system we call it as, and the radix for it is 2. The radix is nothing but the number of symbols in that system, that is zeros and ones. So, whatever you store in the digital format, it will be in zeros and ones. Not only this, there are other systems like octal system, hexadecimal system, and other systems are there, but mostly we will be using decimal system, binary system, octal system, and hexadecimal system in the computers. And most of the addresses, for every memory location there will be an address, and that address will be in hexadecimal. So, studying the number systems is very, very important and is a basic part of the subject. Now, after knowing the number systems, you have to know the Boolean algebra. This Boolean algebra, okay, and there is a special algebra, it is not a normal algebra, okay, what you will be learning in the subject. Of course, this Boolean algebra has come from the mathematics only, but it is particularly used for the designing of digital circuits. If you want to design a big digital circuit, any digital circuit, whether combinational, sequential, or whatever the digital circuit you are designing, your basics of Boolean algebra should be very clear. If they are not, then you cannot design, you cannot design the circuit precisely, because somewhere you will be lacking in the design concepts. So, this Boolean algebra will form the complete base for the digital electronics. In the Boolean algebra, okay, you will be learning the properties, you will be learning the axioms, and the problems related to these properties are very important. Why? Because you have the basics of Boolean algebra, but you are unable to solve any problem related to a circuit. There is a very big equation of a circuit and you want to solve it. Now, one of the simple techniques how to solve or justify certain equations in Boolean algebra is simply substitute zeros and ones in the equation. Now, remember one thing, in the Boolean algebra, this is not a normal algebra. First thing, there will be no number systems in this Boolean algebra, no positive numbers, no negative numbers, no fractional numbers, no complex numbers, no numbers at all. There will be only two values which are called as logical values, we call logic 0 and logic 1. So, whenever there is a big equation, substitution will also be very easy, okay, and we can easily validate that equation by simply putting zeros and ones, whether it is correct equation or wrong equation. So, this is one of the ways we can easily correct the Boolean equations by knowing this Boolean algebra. So, remember, and the special operators in this Boolean algebra are the not operator, and operator, and or operator. Okay, you can call not, and, or. They are the three basic operators, and there are four compound operators which are called as NAND, NOR, XOR, and XNOR. So, total there are 7 operators in this Boolean algebra, and the complete algebra will deal with these operators as well as the relations of these operators and the Boolean variables. Now, Boolean variables, if I say there is some Boolean variable x belongs to integers, okay, if I say a small x belongs to integers, the x can take infinite values, okay, from minus infinite so on till minus 2, minus 1, 0, plus 1, plus 2, so on. But if I say that simple x, Boolean variable, if I say that x is a Boolean variable, not normal variable, then x will take only two values, 0 or 1. Remember, this 0 is not plus 0 or minus 0, and this 1 is not a plus 1 or minus 1. They are simply logical values. All the two level quantities you can express in logic levels, logic 0 or logic 1. For example, okay, tube light is on, you can take it as 1. Tube light is off, you can take it as logic 0. I am living, logic 1. I am dead, logic 0. Okay, video is going on, logic 1. Video is not going, halted, logic 0. True, false, high, low, positive, negative, do, die, active, inactive. So all the two level quantities, enable, disable, like this. Yes, no, all the two level quantities you can represent in logical values, that is logic 0 and logic 1. That is how this Boolean algebra will work, and okay, that will form the complete base for the remaining complete subject. So that's very important to focus on Boolean algebra. Next, coming to the Boolean functions. So Boolean functions, if you want, then again you should have the knowledge of Boolean algebra. So in the Boolean functions topic is also very important. Why? Because for every machine, for every digital machine, whether it may be a combinational machine or whether it is sequential machine or whether it may be a microprocessor also, okay, inside the microprocessor designing, all the digital systems are governed by certain equations, functions, and those functions, if you want to generate, you should have the knowledge of the Boolean functions. Without Boolean functions, no question of digital designing, whether it may be combinational, sequential, or memory circuits, or whatever it may be. So Boolean functions will play a vital role in designing the circuits. Now coming to the K-maps. Why K-maps? Whenever there are big expressions, okay, then the hardware of the circuit will also increase. Okay, we can make a computer of a size of, okay, 1 meter cube. We can make a computer of a simple, okay, of 1 feet square, 1 feet cube. Okay, now that means the size is very important. The portability will come into the picture. Okay, portability will come into the picture, the ease of analysis will come into the picture, the designing will come into the picture, and the power consumption, so many other factors will come into the picture. So the size is very important. Now, with the help of these Boolean functions, you can generate the Boolean functions, but directly we will not go for the design of the systems. So what we will do is, we will try to reduce the Boolean expressions so that the design will be minimal. So if the design of the circuit is minimal, there will be so many advantages. The power consumption will be less, the portability will be more, and also, okay, the designing will be easier, and there are some characteristics for each of the these logic families. Those characteristics we can optimize. That we will see whenever, okay, we are into the subject. Now, so mainly the K-maps is a technique which we can reduce the Boolean expressions directly. But of course, we can reduce the Boolean expressions using this K-map till 5 variables. So the K-maps are used to reduce the Boolean expressions till 5 variables, not more. Okay, if you have Boolean expressions which are functions of some 6 variables or 7 variables, we will go for the other techniques like WEM techniques or tabulation methods. Okay, generally they are not part of the syllabus of GATE, but however, we can learn them because knowledge is infinite. But for GATE particularly, they are focusing on K-maps. Now coming to the next is logic gates. After knowing the basics of this Boolean algebra and these functions, we have to go for the logic gates. So logic gate. So now previously in the Boolean algebra, I told some operators, not operator, and operator, nor operator, and so other operators. In mathematics, we call operators. When it comes to a circuit, they are called logic gates. Not operator or not operation will be done by not gate, end operation will be done by end gate, XOR operation will be done by XOR gate. So logic gates are basically electronic circuits with only one output, where the output depends on the inputs, and these electronic circuits which will do basic logical operations are nothing but logic gates. And there are 7 logic gates. Okay, there are total 7 logic gates, and these logic gates are categorized into 2 groups, the basic logic gates and the one more is compound gates. The basic gates are again categorized into 3, NOT gate, AND gate, OR gate, and these compound gates are categorized into again 2 types, the universal as well as the special gates. In the universal, you will have the NAND gate and NOR gate, and in the special gates you will have XOR gate and XNOR gate. So the complete subject is about the designing of these logic gates and assembling the logic gates into a complex circuits and making different types of circuits like arithmetic circuits, code converters, mux, decoders, demux, encoders and whatnot. So if you understand the logic gates clearly, okay, functionally, then it will be very easy to move through the other topics. We can swim through the other topics. So remember, if you want to be good at the remaining topics, the first section, okay, the basics are very, very, very important. If you are weak in the basics, other concepts, you will be going weak. It's very simple. For example, you want to construct a 100-story building, and for that 100-story building, you have planned some 50 pillars. Let us assume, hypothetically, let us assume there are 50 pillars for a 100-story building. Now, out of the 50 pillars, say 2 pillars are weak, gone. You can't even construct some 5-story building. The meaning of this is, even in the subject it is same. If you want to construct the subject, okay, properly, hierarchically, then your base should be very strong. There is simple pillars here also, that means 2 pillars are weak, no need of all the pillars to be weak. Here also, even in the basics, if you are some little concepts are weak, the further concepts will collapse. You cannot understand certain concepts, you will go weak there. So focus more on the basics. This base is very important.